Chapter 8.4e, graphing y equal a times x minus h square plus k, graphing a quadratic function. Key idea: graphing y equal x minus h square. If the transformation is right next to the x, then it is called horizontal translation. So this is an example of horizontal translation. When h is greater than 0, the graph of y equals x minus h square is a horizontal translation h units to the right of the graph y equals x square. So my regular graph is always start from 0, 0 and it's y equals x square. If you graph something like this, where you're going to move the graph h units to the right, so let's say this is h unit to the right, you shift the graph, the whole graph, h unit to the right side of 0, 0. So this is h unit to the right side. Next is when h is less than 0. The graph of y equals x minus h. So there is a minus sign already here. So if it's h is less than 0, then it becomes positive. So we can treat this as a positive sign, because when h is less than 0, the two negative will become this sign positive. There is a sign negative here, and negative h will make it positive. Then the graph will move h units to the left side. So our parent graph is always start from 0, 0 and follow the pattern. And if it is x plus h, it moves h unit to the left. So it's going to move 1, 2, 3 h unit to the left side, and that's going to be your new graph. So just remember, the horizontal transformation is opposite. When h is greater than 0, if it is x minus h, it moves h unit to the right. If it is x plus h, it moves h unit to the left. Now we are going to discuss example number 1. We are going to graph y equals x minus h square. Now in this case, we have y equals x minus h square. Compare the graph to the parent graph y equals x square and make a table in order to find out the graph of x minus h. So all you have to do is that use these x values and plug it into this x to find the y coordinate. So now I'm going to plug it into the given equations. The first value is 2. So 2 minus 4 square, and that's going to be negative 2 square, and negative 2 square is 4. My first point is 2 comma 4, and my next point is going to be 3 minus 4 square, and that's 1. Negative 1 square, it's 1. 3 comma 1. Next, I'm going to put 4, and 4 minus 4 is 0, and my point is going to be 4 comma 0. Next, I have 5 minus 4 square, and that's going to be 1 square, and this is 1. 5 comma 1. 6 minus 4 square, and that's going to be 2 square, which is 4. And my next point is going to be 6 comma 4. Now we're going to plot these points and get the graph of this y function. So first of all, we're going to make a y-axis and x-axis where we need more space on the right side, because this graph is going to move 4 units to the right. So here is my y-axis and here is my x-axis, and I'm going to first graph this function that is our parent function. For my parent function, I always use the pattern like 0, 0 is my starting point, 1, 1, and 2, 4, 3, 9, and so on. So my first point is 0, 0, 1, 1, 2, 4, and those are enough points to make a good graph, and that's my parent graph y equal x squared. Now I'm going to plot the points for this graph, that is y equals x minus 4. My first point is going to be 2 comma 4, so that's 1 2 3 4 this point. 3 comma 1 is this point, and 0 4 comma 0, 5 comma 1, and 6 comma 4. And when I join these points, I'm going to get a graph that is x minus 4. We can tell from its equation that this graph or this translation is 4 units to the right. So this is 4 units to the right. Now we can graph, or you can understand that we can graph this translated graph without making any table, because we understand that our parent graph that start from 0, 0, from that graph 0, 0, we are going to move this graph 4 units to the right. And after moving that to 4 units to the right, we are going to use the same pattern that we learned, that is after starting from 0, 0, in this case is 4 comma 0, we're going to rise it by 1, 1, and by 2, 4. And then we are going to get a translated graph. This translated graph has the vertex at this point. So the vertex for this graph is 4 comma 0. And the axis of symmetry is the line that goes from the center of x-axis, that is x equals the x value, so x equals 4. So the vertex is 4 comma 0, and axis of symmetry is the line x equals 4. So now we are going to discuss the graph that is x plus 4 square, and we're going to compare it with y equals x square. So first thing I'm going to do to graph this, I'm going to make a parent graph, and I made the y-axis and x-axis. So parent graph is going to start from 0, 0, and it's going to be 1, 1, and 2, 4 on the other side as well. And then you're going to get a parent graph. After that, to make a graph of this function x plus 4 square, it is suggested that we're going to make a graph using this x value and plugging these x value here to get the y coordinate, so that we can plot these points here. So to make this table, I use the -6 and plug it in here. That gives me -2 square, and negative square is always positive. So my point is going to be -6 comma 4. My next point is when I use -5 here, -5 plus 4, that's -1 square, and my next point is -5 comma 1. Next is when I plugged it in -4, that gives me -4 comma 0. And next I'm going to plug -3 here, -3 plus 4, that is 1 square. And my point is going to be -3 comma 1, and then last is -2 comma 4. So I'm gonna plot these points here. So 1 2 3 4 5 6, -6 comma 4, 1 2 3 4. So this is the point -6 comma 4, -5 comma 1, -4 comma 0, and then I have axis of symmetry lines from the center of the vertex, and I can mirror these points on the other side. So this is 2-step here, and that's going to be 2-step here. So this is my point. Or I can just simply use my points that are right here and plot all these 5 points to get my graph that is moved from the center 0, 0 to 4 units to the left. So that's the translation, 4 units left. Where my vertex is the point where the parabola starts. This is this point B, that is -4, 0. And my axis of symmetry is this line, that is center line from vertex, and it's the x value of the vertex. Now I'm going to quickly discuss the U-try problem, where we have a parent function as y equals x squared. So I'm going to graph the parent function on all the 3 graphs first of all. So making a parent function is not very difficult. I just follow the pattern 0, 0, 1, 1, 2, 4, and then I mirror the point on the other side, and I get the graph of the parent graph. So here is my parent graph for the 3 functions, and now I'm going to graph this first one, and then the first one, if it is x minus h, is going to move to the right side. So 2 unit right. So I'm going to move this point 2 unit to the right side, and I'm going to follow the same pattern, that is from the starting point is going to move 1, 1 and 2, 4. So my points are going to be 1, 1, 2, 4, and on the other side as well I get these points, and that's going to be my graph. For the next one, this is +3, so this means it's 3 units left. So 3 unit left, starting point is this one. After that you're going to follow the pattern 1, 1, and it's going to be 2, 4, and that's my graph. Next is, since it's -3, so 3 unit right side. So moving 3 units right side, follow the pattern 1, 1, 2, 4, and the graph is this one, that is translated 3 units to the right side.